Okay, in our last video we saw how we can represent elements using their electron configurations. Today what I want to do is take a step back and kind of look at the periodic table as a whole. What I have is an image from our textbook, and they further break down chunks of the periodic table. And in particular, what they have over here and over here are called representative elements. So representative elements can either come from this side of the periodic table, which is called the S block, or they can come from the P block over here. And if you remember, these were the tricks I used to remember my electron filling diagrams. Okay, so this indicates where the final electron lies within the electron filling diagram. If it lies in either the S block or the P block, it is called a representative element. All right, in the middle here, we've got the transition elements. And if you remember, this is where the d orbitals are. So this is called the D block. And that's where all of the transition elements are. So if the last electron is going into a d orbital of some sort, then we would call this a transition element. And then down below right here, we've got these inner transition elements. These are on the very bottom. This is where the F block is. So this is used to classify the elements. If we're talking about an inner transition element, it means that we're talking about something where the last electron in the electron filling diagram is in the F block. If we're talking about a transition element, we're basically saying that we're talking about an element where the last electron is in the D block, and so on. You may notice that the last one we haven't really talked about is over here. This is the noble gas block. These are kind of unique in and of themselves because they have a full set of electron in all of their orbitals. And like I said, we oftentimes use these as kind of the benchmark and then add electrons onto them. So for example, if we were talking about sodium over here and we wanted to do the electron filling diagram, what we would do for sodium is we would actually say, well, neon over here was the last element before we got to sodium. And then in addition, we'd say, hey, this was 1s, 2s, 3s. And so we could say, hey, if we wanted to represent sodium, we could say the halogen before was neon. I'll put that in brackets. And then we start in on that 3s row to find sodium. So I'd say 3s, and we need one electron to get over there, meaning we're going one column over. So if we were to look at sodium, we would say this is a representative element. All right, it wouldn't be called a transition element, wouldn't be called an inner transition element, and it's definitely not a noble gas. So I would just go ahead and I would classify it this way. All right, I hope that makes sense. I did want to bring up one other thing, and this is the distinguishing electron. Oh, I can't write today. And the distinguishing electron is the highest energy electron in an element. So if we think about the distinguishing element for the example that we just went over for sodium, I would say that it's going to be that one electron within this 3s orbital. So in this case, it would just be that single electron in that highest energy shell, which in this case would just be the 3s. All right. Next, what I wanted to do was kind of take a more holistic view at the periodic table, and I'm going to insert an image again. And let's go ahead and move this image down. Okay, so here's the periodic table, and in this case, you can actually see it's broken down into color types. Over here, in kind of this light purple, we've got metals. So you can see all of the purple on the table. In fact, most of the elements on the periodic table are classified as metals. And then over here, we've got nonmetals. Nonmetals are primarily over in this corner, with the exception of hydrogen. Hydrogen's kind of this oddball over on the left. And in fact, there's actually a study done really recently with hydrogen, where hydrogen, if you squeeze it down tight enough, actually starts behaving like an alkali metal like you'd see in 1A. However, that requires ridiculously high pressures. So under normal conditions, hydrogen is a non-metal. All right, and then in between, we're going to look at metalloids. It's kind of the stair step in the middle here. I don't expect you to remember them specifically, but I do want you to know that it's kind of the stair step, starting with boron, going down through silicon, arsenic, and so on. These two kind of stand out, but as long as you remember that there's metalloids kind of at this crossover, you should be good enough. All right, so let's classify what makes a metal, a metalloid, and a non-metal, a non-metal. So let's make some list of characteristics. So the first one is metals. Metals have thermal conductivity, or at least generally they do. And what does that mean? It means that if you heat it up, it transfers that heat really well, which is why we use metals, for example, wires, in heating elements. They're really easy to transfer heat. All right. They also have good electrical conductivity. So if you think about the wires in your house, they're made of copper. Copper in this case is a nice metal. It's great at conducting electricity. All right. And then the next one is a different sort of word. It's ductility. And what this means is that you can form a wire from it. So with most metals, you can actually draw them out, kind of like copper, and form a wire. There are some that don't quite do this. In fact, there are some that are actually liquid, like mercury. But for the most part, most metals can be drawn into wire. All right, next one is malleable. And what this means is that it can be pounded thin, meaning it's not brittle. Something like gold, you can actually pound down into an ultra thin sheet that's only a couple hundred atoms thick, and you can put gold leaf on fancy furniture or artwork or things like that. And then the last one is just kind of common sense. It has that metallic luster. And what does that mean? Well, it just means it usually looks kind of shiny, right? Versus non-metals over here. Let's make a list for non-metals properties. All right, a non-metal is often a brittle or powdery solid. Or a gas. Again, this isn't the definitive list of metal characteristics and non-metal characteristics. In fact, there are a few non-metals that are also liquid, like bromine. If we look at bromine, bromine's actually just a weird red liquid, but it's definitely not going to behave like a metal, and it's going to fall more in that non-metal category. All right, last but not least, we've got metalloids. And as you can imagine, metalloids are kind of in between. And this makes them kind of special. So they have some properties from each of these. So my favorite one that I like to talk about for metalloids is silicon. So if we think about silicon, this is commonly used in the semiconductor industry, right? So silicon wafers are used in the semiconductor industry because they have both the properties of a metal and non-metal, which means they have very, very unique properties. Boron's another really interesting one where it behaves both like a metal and a non-metal, but silicon's definitely the one that impacts our economy the most. All right, so this is kind of our broad view. In our next video, what we're going to do is we're going to look at some of the trends within the periodic table, but let's just pause right here.